a gadget called LRF, called laser signal, in which case usually is infrared. The jet laser. And jet laser hitting the target and then refraction back by doing the quick calculation of the time, and they can precisely calculate how far away from the target. And then, after they doing all this, ranging, then they do a quick calculation, what angle they have to use, what is the initial velocity they have to use, they fire the gun. Usually, when they fire the cannon, basically is plus minus 5 feet accuracy. Plus minus 5 feet accuracy. And ladies and gentlemen, we'll hit right on. That's the reason why in Iraq, we won the war. You don't know now. And in reality, in 1960, 1970, we're supposed to win the war in Vietnam. But due to Jenny Fonda, all those women actresses, they are against the war, so we failed. They protested with the accuracy we should aiming at the 10 at no time. And back in 1968 and 1970, I already working at Xerox, doing the laser rangefinder, doing the jet laser and so forth development. And because of working there, give me a lot of opportunity. Because I'm doing the things in the frontier, so that I got a lot of offer to go to different company to work, and then at the same time that the Taiwan government later asked me to go back to teaching and stuff. So that's good. So now this rangefinder, you know the range. So after we getting this formula or relationship, you have to figure out what the significance it tells me. What does the significance tell me? Okay, so you as an individual look at this. Don't just memorize the equation, memorize the significance of it. In my class, you don't have to memorize any equation, any formula. In the test time, we will make up the formula sheet for you. Okay? So we want you to understand rather than like Raymond Lu mumble, x squared equals plus 5 squared equals z squared, like that, okay? Spend a lot of time memorization. We want you to understand. So what is this things to tell you? Number one, you have to find what is most important for doing the projector. Range, right? So what is the ideal range? Maximum. With minimum effort, I can get maximum. Just like you go to casino, using $1 to win million, right? That will never happen. But in the reality, in this, you have the proper formula, it will work. So you want the maximum. So what dictates the maximum value? The functional sign. What is the functional sign give you maximum value? Sine what angle? Sine of what angle give you maximum?
45.
Yeah. Sine 90 degrees will give you 1, right? That's a maximum. 1 only is 1. So sine 2 theta equal to 1. Then R is equal to maximum. So now we were looking at that is how to make the sine 2 theta to 1 is 90 degrees, right? So theta equal to 90 degrees. So what did that say? Theta is equal to 45 degrees. So R maximum, theta equal to 45 degrees. So what does that give you? All those efforts when they shoot the ball, throw the ball, they all have to aim at 45 degrees. They give you maximum range. Even though you're going to do that, what we call what you call
Golf.
the golf. So why you want to play golf? You want to meet the rich people, potential investor. Okay, so a lot of people doesn't understand that. That's where the rich people go. So if you're handing the bag for him, if they consider you're a good kid, they say, okay, I give you $1 million to invest. Something like that. So very tempting. So now we like to draw another thing. So here you go. Here is the range. So we're using the 45 degree as a reference. So 45 degree will give you the maximum. So they're hitting here maximum. Okay, now, so the whenever something happens in here, is very nice. So then in particularly, there's some time like this. If this one with alpha, like this, and an angle smaller than, less than alpha, and on the top of alpha, will come to the same point. Using 45 degree as a gadget, as a reference point, that means plus minus alpha respect to the 45 degree line, they will all have the same range. So what I try to say is this: R sub I, R equal to V sub I square times psi of 2 beta minus alpha divided by G is equal to V sub I square sine 2 beta plus alpha divided by G. So what does that turn out to be? How can you prove this? Sine 2 beta minus alpha equal to sine 2 beta plus alpha. That's all. That is going to be one of your potential problem in the first midterm. So I already tell you what I'm going to ask. For example, so other teachers do, they don't tell you. They also then in the midterm, their problem coming up, and oh, the teacher is very smart. And so I just cover 3.3 section on the projectile motion as presented in the book. So there's a lot of stuff you might have to go over again in the book. And presentation are a little bit different than what they did and what I did. So now I want to mention this once more about certain type of projection. So we are talking about projection right now is something like this. So what happened to the other projection like this? So we have to mention the projection something like this in chapter 2. So what happened to the projection something like this? All these different type of projection can utilize the things we have learned. The only thing is you have to separate the situation along the x direction. So we are primarily consider only along 2 dimensions. So the 2-dimensional thing we have like Vxf equal to Vxi plus ax times t. Okay, we have that formula go through this. Now there's another one in which case is 3 atom. All these are useful formula, and of course on the test we will give to you. But basically, for you, after you use a couple of times, you basically memorize it already. X of f equal to x of I plus 1.5 Vxi plus Vxf times t, and then xf equal to xi plus Vxi times t plus 1/2 ax times t squared. And then we have a v sub xf squared equal to v sub xi squared plus 2ax times x sub f minus x sub I. So this is called along x direction. X direction. So now we like to do is along y direction. Y direction. So along y direction, the only thing you have to do is this is along x. You only can change from x to y direction. So v sub yf equal to v sub y sub I plus a sub y times t, and then yf equal to y sub I plus 1/2 v sub xi plus v sub xf times t, and then y sub f equal to y sub I plus v sub yi times t plus 1/2 ay t squared. And then v sub xf square equal to v sub xi square plus 2ax 2ay yf yi plus 2ay yf minus yi. The nice thing about this is redundant. So it's just switching around and then you're getting the new one. Okay, so anything?
Would that be y too, that next line
This one?
in the parentheses?
Oh, okay, thank you. Yi. The teacher needs those kind of help in order to make the lecture more useful. If I make a mistake here, then everybody copy the same mistake. So this is the information. This is all different cases for it. But all these cases can solve it by this. As a matter of fact, we demonstrate that using this equation, and we solve this horizontal. Now there's another one is in your book. There's a homework. This particular homework, you have to read the English very, very carefully. So on the chapter 3, please read the homework number 61. I want you to find out yourself. Look at the diagram and read the English later on. I will tell you the English is wrong. Okay? So to find out what is wrong, and then you come to tell me. Your English is supposed to be better than Wayman English, okay? So read it carefully. So on that part, the problem is the projectile is different. That part, projectile is again it's horizontal, and then they have a boat in here shooting the gun. So here is a mountain. So that they're shooting this, gonna pass that, and he's shooting here and pass that. So to someone. So with different angle, it goes to different direction. So suppose you have a battleship in this area. Where is the best place to be? This is another thing to do. It's very practical. So all this basically you can solve